Okay, so question one, vectors and scalars. A has velocity in the scalar column, velocity is a vector. B has momentum in the scalar column, and momentum is a vector. C has work done, which is energy, and that's scalar, and that's in the correct column. So let's look to the right. Velocity is a vector, and that is in the correct column as well. So the answer there is C. Question two, we want to work out average acceleration. So acceleration is the change in velocity over the time taken. The final velocity is 35 meters per second. The object starts at rest, so it's 0 meters per second as the initial velocity. The time taken is 8.5. So the change in velocity over the time taken is 4.2 meters per second squared, and that answer is B. Question three, the unit for energy is the joule, and which base unit is equivalent to that. So what we've got here is work done, which is energy, is force times distance. So if you forgot the base unit for standard base units for force, then you can expand that formula out to mass times acceleration. Mass we know is kilograms, acceleration is meters per second squared, times by the mass, and you'll get kilograms meters squared seconds to the minus 2. So the answer is B. So if you look at part A, that's force, and part D, that there has another seconds to the minus 1 on there, so that's power. Question 4, we're going to calculate the acceleration from a velocity time graph. So that is a gradient. So the gradient here is the rise over the run. I've chosen a triangle. You could choose a different size triangle if you want. So rise is 20 meters per second, run is 2 seconds. So change in velocity over time, 20 over 2, 10 meters per second squared. So the answer is A. Just put that there. Okay, next question 5. It's a displacement time graph, and if we want to find the velocity on a displacement time graph, you need to take the gradient. Now at 2 seconds, it is a curve, so we need to draw a tangent. So I've drawn a tangent here, and I've chosen a triangle there, and the rise is 20, the run is 3, and 20 over 3, 6.6 recurring, approximately 7, and that is answer A. Question 6, physical quantities can be vectors or scalars. So there are three statements. We're figuring out what is the incorrect word or symbol in the statement. So what do I need to do to make this correct? So a car has a weight of, rather than kilograms, weight is in newtons, so that should be newtons, and weight acts vertically downwards, not vertically upwards. The second statement, it says the velocity of light is 3 times 10 to the 8 meters per second. Velocity has a directional property, but speed is a scalar with no direction property, and that is the correct term to use here. So the speed of light from the sun is 3 times 10 to the 8 meters per second. And finally, the car speeds up with a deceleration of 2.5. A deceleration, that signifies the car is slowing down. So if it's speeding up, it's an acceleration. Question 7, we have a car going through a speed camera. The markings on the road will help the speed camera determine whether the car is breaking the speed limit or exceeding the speed limit. So what we have here is that each photograph that the camera takes is over a period of 0.6 seconds. So it says explain why the speed calculated is an average speed. One thing that crops to mind straight away is the speed can continuously be changing, so varying. That should be in your answer. And the average speed, what is average speed? Average speed is calculated by dividing the total distance by the time taken. So that's how we calculate it, using the entire distance that the car has traveled between the interval of 0.6 seconds. And we know that there is an average speed, so that implies that the speed could be changing in between, and that has to be in your answer as well. Now, this photograph here is where the car is at the beginning. This photograph is at 0.6 seconds later. The distance between each interval is 1.54 meters. And if we look the car before and after, these lines will help determine how far the car has moved. 1, 2, 3, 4, 5, 6, and a bit. I would say 6.2 is an approximation, squares or interval, sorry, and each interval is 1.54 meters. So therefore, the distance is 6.2 times 1.54. That's 1 mark. The time is 0.6 seconds, and the speed will be the distance over time, and that works out to 15.91 meters per second. We can't compare that to 50 kilometers per hour because the units are different. So what I'm going to do is to convert that into kilometers per hour, divide by 1,000 to get meters into kilometers. And because it's seconds to the -1, that would be divide by 3,600, or times by, because it's at the bottom of the fraction, that inverts, and that would be times by 3,600 to get kilometers per hour of 57.3. And we see that 57.3 is greater than 50 kilometers per hour, for therefore the car has exceeded the speed limit. And finally, part C, parallax error due to angle of the camera. So here's the picture. Camera suspended at a certain height. It will see the, let's say, front edge of the car with this position on the road, and then the front edge of the car with this position on the road. So there's an error in the reading here and the error in the reading here as well. That is called parallax error due to the angle of the camera.